Let's start with ionic bond. Let's take the first example, which is sodium chloride. Sodium chloride starts from sodium atom here. Sodium atom has 11 electrons, so we'll distribute them here in their shells. Okay, and chlorine atom has 17 electrons, so we distribute the 17 electrons in the shells. As we see, both of two atoms are not stable because they do not have a stable outer shell. So what to do here? According to the stability of sodium atom, it will lose this electron. But from where? Where we got this electron? And here we have chlorine atom, which has 7 electrons in its outer shell, and actually it's not stable. It needs only 1 electron to become stable. So we have a deal here. Okay, what will happen for this deal? This electron in the outer shell will transfer to the outer shell of chlorine atom. What will happen as a result of the transferring of electron from the outer shell of sodium atom to the outer shell of chlorine? Both of ions will become stable because they got a stable outer shell. So sodium ion has a positive 1 charge and chloride has a negative 1 charge. Okay, if you look to the outer shell here, it's stable because it's filled with 8 electrons. Here the outer shell of sodium ion is filled with 8 electrons. Both of ions are stable. And if you ask yourself about what is the overall charge of sodium here in sodium chloride, it will be 0 because you have negative 1 and positive 1, so the overall charge is 0. So sodium here is a metal, chlorine is a non-metal. Okay, we have two opposite charges, so they attract to each other. So the force here is electrostatic force, or the force of attraction. And here we have ionic bond. Okay, let's take another example. Magnesium oxide. Let's start with magnesium atom, which has 12 electrons. We distribute the 12 electrons in shells as we see here. So the outer shell will be filled only by 2 electrons, which is not stable. Alright, what about oxygen? Oxygen has 8 electrons, but it has 6 electrons in its outer shell. So it's also not stable atom because its outer shell is not filled by 8 electrons. So magnesium atom will transfer its 2 electrons from the outer shell to the outer shell of oxygen, causing magnesium oxide. Okay. We got here a filled outer shell of magnesium ion, which is 8 electrons after transferring 2 electrons from its third shell. And we got filled outer shell of oxygen here. It becomes oxide, and its outer shell will be filled by 8 electrons, and now it is stable. So here we have magnesium oxide. Guys, let's draw magnesium chloride. We start with magnesium atom, which has 12 electrons. After distributing of 12 electrons, we find out a magnesium atom is not stable because it has only 2 electrons in its outer shell. What about chlorine atom here? It has 17. After distributing of 17 electrons, we have only 7 electrons in the outer shell. So it's a good idea. One of these electrons will transfer to the outer shell of the chlorine. But we still have a problem. 1 electron remained. Well, here, what to do? So we have to draw another chlorine atom, okay, just to compensate the shortage. And here we'll transfer another electron from magnesium atom to another chlorine atom. What happens as a result of the transferring of electrons between magnesium and 2 chlorine atoms? Magnesium becomes magnesium ion with positive 2 charge, and both of the chlorine atoms become negatively charged and gained 1 electrons with stable outer shell, and here we have magnesium chloride. Its formula will be like this: MgCl2, which means 1 magnesium atom with 2 chlorine atoms. Okay guys, if you have any questions about the lesson here, you can ask me in the comments below, or you can ask me by sending a message. So thanks a lot guys for watching, and have a nice day. Enjoy your time.